So this video is on Friday, May 28th's homework, which is verifying trig identities worksheet number 5. So on this first one, again, remember, we're always trying to keep the right-hand side. We're going to make the left-hand side become the right-hand side, okay? So I want to end up getting a 1 over secant x is what I want. Okay, so first thing I'm going to do is let me rewrite these in terms of sines and cosines, and then I'll clean it up. So secant x, and I do want a secant x, but let's kind of see what happens here when I rewrite this. Okay, so secant x is 1 over cosine x. My tangent x is going to be a sine x over cosine x times sine x. So they're both over over cosine x. So I really can rewrite this as 1 minus sine squared x over cosine x. And then for this, what I'm going to end up getting is this 1 over sine squared x is going to be equal to, because I'm just going to drop this here, cosine squared x plus sine squared x by Pythagorean triple equals 1. So if I am subtracting sine squared x from both sides, I'm going to get 1 minus sine squared x, which is the same as cosine x. So in place of this, I can write cosine squared x. Okay, so let me rewrite this. So again, my focus is I'm trying to get 1 over secant x. That's what I'm trying to get. Okay, so this is going to be cosine squared x over cosine x is equal to 1 over secant x. This 1 over cosine squared x is going to be a cosine x is equal to 1 over secant x. And the reciprocal of cosine x is secant x. So I can rewrite cosine x in terms of its reciprocal. So this is going to be, cosine x is the same as 1 over secant x. And so I get 1 over secant x equals 1 over secant x. Check. Okay, number 2. Okay, so on number 2, I'm trying to get a cosecant x and a cotangent x. And just real quick, cosecant x is really a 1 over sine x. Cotangent x is a cosine x over sine x. So that's kind of what I'm trying to get. So what I'm going to do is I'm going to actually split this fraction. So I can take 1 over sine x, and cosine x over sine x. And we're trying to get this to be cosecant x plus cotangent x. That's our goal. And then 1 over sine x is cosecant x. And cosine x over sine x is cotangent x. So I ended up getting cosecant x plus cotangent x on both sides. On number 3, Okay, we're trying to get a sine squared x. So first thing I'm going to do is maybe rewrite everything in terms of sines or cosines and kind of see where we go from there. So the secant x is going to be 1 over cosine x times sine x. Okay, I'll leave that sine x as is, over my tangent x. My tangent x is going to be a sine x over cosine x. My cotangent x is going to be a cosine x over sine x. Okay, so that's what I have so far. And again, I'm trying to get sine squared x is what I'm trying to get. Okay, so looking at this, I am going to multiply the whole entire top and the whole entire bottom, so I don't have fractions in fractions, by cosine x sine x. Cosine x sine x. Now on top, what's going to happen is this cosine x and this cosine x are going to cancel, and I am going to be left with sine squared x. Then on the bottom, when I'm doing this, I am going to have this multiplying with both of them. So what I cancel out, I'm canceling out temporarily. The cosine x sine x is actually multiplying both of them. Maybe let's do it like this. Like that. And then cosine x sine x. Okay, because I have two terms on bottom. Top, I only had one term. Okay, so I am going to have this cosine x and this cosine x cancel out. And I'm going to get sine squared x. And I am going to have this sine x and the sine x cancel out, and I'm going to get cosine squared x. And again, our goal is to get sine squared x. Well, this denominator, sine squared x plus cosine squared x, that's just 1. Okay, so I am going to end up having my sine squared x over 1 equals sine squared x, and sine squared x over 1 is just sine squared x equals sine squared x. There we go. On number 4, we're trying to get a 1. Again, I'm going to rewrite each of these. So let's see, secant x is going to be a 1 over cosine x. Okay, here, let me write that better so it don't, it's like a cosecant or something. 1 over cosine x over cosine x. I haven't done anything with that yet. Okay. And then this tangent x is going to be a sine x over cosine x. And then my cotangent x, this is going to be over, let me do that in black, over, and then my cotangent is going to be a cosine x over sine x. And again, my goal is to get a 1. Okay, so now if I'm looking at these fractions, okay, so this fraction here, I have a 1 over cosine x divided by cosine x. So what that becomes is a 1 over cosine squared x. Okay. And then the second part here, when I do this, I am going to get, here, let me highlight it. Okay, so this, I am going to have a sine x cosine x times the reciprocal, which is a sine x cosine x equal 1. So now I am going to have a 1 over cosine squared x minus a sine squared x over cosine squared x equals 1. Both of them are over cosine squared x. So I can write it as a single fraction. I can write it as 1 minus sine squared x over cosine squared x equal 1. And then this 1 over sine squared x, remember the Pythagorean identity, that cosine squared x plus sine squared x equals 1. So if I was to keep the cosine squared x on this side and subtract my sine squared x, I see that this right here is the same as this, so that I can rewrite as a cosine squared x. So I'm going to have cosine squared x over cosine squared x equals 1. And so I get 1 equals 1. 1 equals 1. There we go. Okay, on number 4, oh, sorry. No, should be 5. This says 4, second 4. Okay, so I'm trying to get a 1 minus 2 sine squared x. So what I'm going to do is remember what I just said a second ago, that cosine squared x plus sine squared x equals 1. I'm trying to get sine, so if I rewrite this, cosine squared x is equal to 1 minus sine squared x. This is what I'm going to use right here, this idea, and I'm going to put it in place of this. So I'm going to write 1 minus sine squared x minus sine squared x equals 1 minus 2 sine squared x. And when I clean that up, I'm going to get 1 minus 2 sine squared x equals 1 minus 2 sine squared x. There we go. And on 6. Okay, so I have a tan squared x sine squared x equals tangent squared x minus sine squared x. So again, trying to get this. Okay. So on this one, so I want to get my, sorry. So I have a tangent squared and a sine squared on both sides, but I need it to be a minus, not to be multiplying. So what I'm thinking of doing is I'm thinking of keeping my sine squared as my sine squared, and I'm thinking of rewriting my tangent squared x. So just a little reminder, I can write the formula out, but I want us to understand where it came from. Sine squared x plus cosine squared x equals 1. If I was to divide by cosine squared x, cosine squared x, cosine squared x, I would end up getting tangent squared x plus 1 equals secant squared x. I'm going to be using this formula, and I'm going to be rewriting it as tangent squared x is equal to secant squared x minus 1. This right here is what I'm going to do with this tangent squared. Okay, so that's what I'm going to do. So I am going to just kind of write this here. in place of my tangent squared, I'm going to write secant squared x minus 1, okay, times my sine squared x. And my goal is to get tangent squared x minus sine squared x. I am going to distribute. So when I distribute my sine squared x, I'm going to get secant squared x sine squared x minus sine squared x. And again, we're trying to get tangent squared x minus sine squared x. Well, I have my minus sine squared x. And this right here, I can rewrite my secant as a 1 over cosine squared x. So that's sine squared x over cosine squared x minus sine squared x equals, and again, we're trying to get tangent squared x minus sine squared x. So now this is tangent squared x. So I now am going to have on this side tangent squared x minus sine squared x. And on the other side, I also have tangent squared x minus sine squared x. There you go.